Hello students, in this video we are going to study about the socket programming. So the session agenda is what is socket programming and what are the different types of sockets and what is the interaction between the client and server. So to start with, what is socket programming? So what is the meaning of socket first? A way of connecting two nodes on a network to communicate with each other. So imagine like a bridge between two cities. So if two cities need to perform their transportation from city 1 to city 2 or else from city 2 to city 1, we need a bridge. Similarly here, client and server are like two cities. If those client and server needs to communicate with each other, we need the help of a socket. So the socket is a way of connecting the two nodes. Here two nodes are known as the client and server. And this is established with the help of some logical pipes. So if you want logical pipes in the sense they are not physical in nature, they are inbuilt, which is depicted with the help of a program. And these logical pipes helps in communicating from one device, that is one computer, to another. If you want to implement the socket, we need to use the socket programming. The socket programming contains a set of system calls to service from TCP/IP protocol stack. So TCP/IP protocol stack, as we have learned in our OSI model, so this particular TCP/IP stack is necessary in order to perform the socket programming. So how it is useful and where it is useful, we'll be seeing in the upcoming slides. So before starting our socket programming in detail, we need to understand one thing very clearly. So this is the overall diagram of the socket interaction among the client and server. Imagine there are two systems, that is the two nodes, that is either client and the server. So the client also initiates the socket, server also initiates or creates the socket. After creation of the socket in both client and server binds with the particular address, and then the server starts listening. Once the server starts listening, the client connects with the server. When the server receives a request from the client to connect, it will accept that particular request. And once if the server accepts the request, the client sends the messages to the server. And the server will receive the message. And in turn, if the server wants to send some message, it will again send it to the client. So this is a two-way communication among the client and server. Once if the communication is done, both server and the client will close their or terminate their connections. So here in this particular slide, I'm not explaining anything about bind, listen, accept or connect or socket, whatever it is. So we'll be learning about this in the upcoming slides. Types of sockets. So how many types of sockets do we have? Number one is stream socket. So the stream socket is nothing but it's a reliable connection as well as connection oriented. So in short, we'll call it as a TCP, that's a transmission control protocol. If we want to implement a TCP socket or a stream socket in our programming, we need to use sock_stream keyword. And if it is a datagram socket, then we have to use sock_dgram. So this datagram socket is unreliable in nature and it is connectionless. So in short, we'll call it as UDP, User Datagram Protocol. So in our upcoming programmings, we'll be using both these sockets, irrespective of the programs. So first to start with, we need to know about the structure of the socket. The structure of the socket is a predefined one, which is defined as struct sock_addr_in. So without using this predefined socket, we cannot establish a socket or we cannot create a socket. So how does this structure look like? So first we have to mention the struct keyword, and then we have to use the sock_addr_in. This is a structure name, and inside that we have some data members of that structure. The first data member is SIL_family. Structure So the IP address are of two types. One is IPv4 and another one is IPv6. But in our series of programs, we are going to concentrate only on IPv4. And in order to indicate that, we will be using this SIN underscore family data member. The second data member is SIN underscore ADDR dot S underscore ADDR. This specifies the local address, and in our particular programming, we'll be using INADDR underscore any. It represents the local address of the computer in which we are working on. In case if your system is connected not in the local address, if you want to connect to some remote address, then you have to specify the remote IP address over here. Since we are not going to connect to any remote address, we are going to connect only as a standalone application, then we have to use INADDR underscore any. The third data member is to specify the port address. So in order to do that, I have a data member known as SIN underscore port. It specifies the port number. And one more important thing is, since different computers use different byte orderings, internally the port number needs to be converted. So every system has its own byte orderings. So the port number, whatever you are specifying, has to be converted from the host byte to a network byte. Because the host indicates the system in which we are working on, and the network byte indicates in which network our system is connected. So in order to convert, we need to specify, you need to use that H2NS port. H2NS is nothing but host to network short. So if you want to understand this, what is this host to network short, we need to learn about Little Endian and Big Endian. And if you see this diagram over here in Little Endian, this is a particular address or any hexadecimal digit. Imagine we have 0A, 0B, 0C and 0D, and the digit starts from 0, 1, 2, 3 from right to left. And if you notice in Little Endian, the digits are counted from 0 and 1. First two digits 0 and 1 are stored in the first memory location, and 2 and 3 are stored in the second, 4 and 5 are stored in the third, 6 and 7 are stored in the fourth memory location. As you can see, everything is going in ascending order. So Little Endian moves in an ascending order, whereas the Big Endian goes in the descending order. Here you can see that 7, 6, that 0A is stored in the first memory location, 0B is stored in the second memory location, and so on. So in order to convert this host to network, we need to understand about Little Endian and Big Endian. So this is the format in which we are going to convert. So to start with the client and server interaction, major operations of server, as I have shown in the diagram before, we have around 4 functions, that is creation of socket, how to bind, and how to listen, and how to accept. These are the 4 major operations done by the server. And what are the major operations done by the client? Only 2 major operations, that is creation of socket and connect. Since these are the major operations, the other operations are like send and receive, which is universal among client and server. But these alone are separated among the client and server. So first we'll see about how to create a socket. If you want to create a socket, then we need to use the socket function, and it contains 3 parameters, that is domain, type and protocol. The first parameter is domain, which is used to describe about the communication domain. That is either it may be IPv4 address or IPv6 address, as we have seen in the previous lines. If it is an IPv4 address, then we need to indicate that in the program using the keyword AF underscore INET. If it is IPv6 address, then we need to indicate in the program AF underscore INET6. So this is about the domain specification of the socket. And mostly in our program, we are going to use AF underscore INET, which means we are going to use IPv4 address. And number 2 is type. Type describes about the type of socket that is to be used in the programming. So as I discussed in the previous slides, we are going to use only 2 types of sockets, TCP and UDP. If it is a TCP, then we have to use sock underscore stream. If it is a UDP, we have to use sock underscore GRAM. And the third and the final one is protocol. It is used to specify the internet protocol that is used. And by default, we can specify with the value 0. So which type of internet protocol are we using? So default value will be 0, and throughout our program we'll be using the value 0. The second most important operation of the server is bind. Why we have to bind? It is used to reserve the port for the socket. So every socket is connected to a port. So what is the meaning of this port? Port is nothing but like a phone number. If we want to communicate with our friend, we need a phone. Yes, we have a phone, we created the socket, we have a phone, landline, we have a device. Now, if I want to initiate the connection, if I want to talk to my friend using that phone, then I have to bind the phone with the address of the connection. So in that case, I need to use this bind function. It is used to reserve the port for the socket. So in which port that particular socket needs to communicate. That I can bind using this bind function, and there are three parameters: sock ID, address port, and size. Sock ID is nothing but the socket identifier. What is the socket ID? And the second one is address port. As I already discussed, since we are using only the local address, we are going to specify only the in addr_any. And the third one is size. So we need to use the size of function in order to know the address of our socket structure. Next operation is about listen. After binding, the server needs to listen to the client if any clients are being requested. So what is the job of listen? It puts a server socket in a passive mode. It means it's not active until the client issues a request. Until the client issues a request, server is in a passive mode where it waits for the client to approach the server to make a connection. So client needs to approach the server, so server will start listening to the client. And we have only two parameters. As I already said, sock ID indicates a socket identifier. And what is this backlog? Backlog defines a maximum length of the queue. So server can listen up to how many clients in the queue. It depends on the user. He can specify up to 5, 10, any number. So server, if whatever backlog number is specified here, only that many client connections can be received by the server. The next one is important, is about accept function. It extracts the first connection request on the queue of the pending connection. So once the bind function is over, the next connection will come to the, after bind, the server starts listening. Once the server starts listening, the client will initiate the connection using the connect function. Once the client initiates the connect function, the server will accept it. After accepting, now the connection is established between the client and the server. And now server is ready to transfer the data, or the client is ready to transfer the data for a two-way communication. And this is the syntax for that. So these are the various operations of server. And operations of the client, I already said in the slides. We have our own connect function as well as the socket function. I hope you understood this. Now we will just go to our first practical program, that is to create a socket and to establish a connection between the client and server.